Dear students, today we are going to see about Unit 5. Unit 5 is about display. So the first thing is we are going to discuss about 7-segment display. So, the 7-segment display is presented here. It contains the segments A, B, C, D, E, F as well as G. Okay, since you can see there are 7, it supports 7 segments of line. It is called 7-segment display. So it is an electronic display for displaying the numerical numbers or alphabetical numbers. Okay, it is widely used in digital clocks, electronic meters, and in very basic calculators. It is also known as 7-segment indicator. It consists of 7 LEDs. Okay, so these are the 7 LEDs. That means it contains 7 diodes which are connected in a manner to display some numerical and alphabetical characters. So each segment of LED is denoted by the letters A to G. You can see it is denoted until A to G. So for displaying the letter A, what are the possibilities? A will be available, the segment B will be available, C, D, E, G. They all will be available except F. In some of the 7-segment display, we'll be using one more segment which is called as dot. So the dot will be the 8th segment. Okay. Since we are learning about the 7-segment display, I don't want to take you to the dot segment. Let's discuss about the 7-segment display. So this is the circuit diagram of a 7-segment display which is connected with the decoder, or you say driver IC. So it contains 4 inputs. All the 4 inputs are BCD inputs, binary coded decimal inputs. Okay, so like to display first character, a numerical value, all the inputs A, B, C, D, everything will be treated as 0. To display the numerical value 1, the A will be displayed as 0, B will be displayed as 0, C as 0, and D as 1. It follow the BCD input signals. Okay, so now the inputs are connected like this. The output will be what it depends upon the segments A, B, C, D, E, F as well as G, which is given to the 7-segment LCD. And also it works with the voltages. Okay, so there are 2 levels of voltages, a positive voltage and the negative voltage. So the voltages are connected to the segment and also to the BP. BP means it is a back plane. So LCD segment, it contains 2 planes, back plane as well as the front plane. Okay, to make a good connection with respect to the voltages, this back plane as well as the front plane are used. So when the voltage is 0, what happens? The segment will be effectively invisible. So if there is no voltage, you cannot find any of the segment displaying. Okay, so but when the voltage is given, when the voltage is above 0 volts, any one of the segment will be displaying, or more than one segment may display. Okay, so all the segments, whatever the segments we are using, they are nothing but LEDs. They are light emitting diodes. Okay, so when the drive voltage has a significant positive or negative value, when it has a significant positive or negative value, the segment becomes more effectively visible. Okay, it doesn't depend upon only the positive values. Every time the segment, the LEDs will transfer from a positive to negative value or negative to positive value to keep on fluctuating between the voltages. Okay, this is because If a continuous positive value is alone given to the segment, that means it will damage the LCD, like when it is permanently visible, no further values will be visible. For example, if a segment is given a positive value alone for a long time, that means this a segment is going to be permanently visible no matter how. If even a segment is treated as 0, you can still receive the light from this segment. Okay, so for this purpose, to avoid this kind of things, the voltage is it is not a permanent one. It will be transmitted between the positive as well as the negative voltage. Okay, so that what happens, when the voltage is varying, you won't be receiving the continuous on signal. Okay, that is how the damages are prevented. But at the same time, when the voltage is 0, the segment will be kept off. Okay. Now you see the tabulation for the display. You can see for displaying a numerical value 0, you can see when you display a numerical value 0, all the segments except G will be kept on. So G segment should be off. Okay, similarly, to display a numerical value 1, you can see B as well as C segments are kept on, all other segments are 0. It is treated as 0. So this like this you can type the numerical value starting from 0 to 9. Okay, and also you can effectively type the alphabetical values from A to F. You can see for B as well as D, if it is mentioned in alphabet, it will be like it will cover all the 7 segments. So in order to differentiate the alphabets B as well as D, we are using small b as well as small d. Okay, and the next is about key pressing or key switches. Generally, the key switches can be classified into mechanical key switch, membrane key switch, capacitive key switch, Hall effect key switches. Okay, so out of these key switches, what we are going to take, we are going to discuss about how key pressing is happening in terms of a keypad. Okay, so these are some of the types, and you can see keyboard interfacing. Okay, how the keyboard is interfaced with the other peripheral devices. So in this example, I have taken the peripheral device to be 8255. This 8255 is connecting with the keypad. You can see the circuit of the keypad. This is the circuit of the keypad, which is utilizing port A. Okay, so this 8255, it contains two ports, port A as well as port B. So one of the rows or columns are connected to the port A, and another rows or columns are connected to the port B, and each port is supported by 4 signals. It starts from PA0 to PA3, and here it supports from PB0 to PB3, that is port B signals. Okay, it also contains chip select signal. So chip select signal should be low, that you know from the memory interfacing. Okay, so all the signals, the addresses are selected except A1 as well as A2. So you are using two address lines for interfacing with 8255, and also it uses data bus, 8-bit data bus. It starts from D0 to D7. It also uses two signals, IO read as well as IO. It is not L, it is IO write, and along with the reset signal. Okay, so when the voltage is given and when any one of the switch is enabled, it is going to display the letter. So this is the circuit diagram which represents You can see it starts from the numerical value 0 to 9, and A, B, C, D, E, F, the hexadecimal values are displayed here. Okay, so now how it is, it can be when a particular key is pressed, maybe the port 3B3, it may be connected to the port A0. That means if this particular key is pressed, that means it is going to display 0, or if this particular key is pressed, that means it is going to display the numerical value 5. It goes like this. Okay, so port A is used as an output port for selecting the row keys. Okay, for selecting the row keys, you are using port A. Is used as an input port for the closed key. You can see this is used as an input port for sensing the closed key. Thus, the keyboard lines are selected one by one through port A as well as port B lines and pulled continuously till a key closure is sensed. Okay, so suppose, for example, if the user wants to press the key 9. Okay, so as soon as the user press the key 9, okay, the numerical value 9, what happens? Sometimes the key debouncing can happen. Okay, so key debouncing means when the user is intended to press the numerical value key, the neighboring keys can also be affected because of the mechanical vibrations, a very small mechanical vibrations. Okay, so to avoid this cannot be avoided, because you know the keys are, they are the hardware things, it cannot be avoided. So for the key debound, in order to check out the key debounce errors, what we are using two techniques, that is software debouncing as well as hardware debouncing. Why we are going for the to detect the debounce is when the key 9 is pressed, it also, due to the mechanical vibration, the other keys can also be affected. The surrounding keys can also be affected, and the circuit may think that all the keys are pressed at the same time. Okay, so you can see keypad debouncing. So I said that to detect the keypad debouncing, we are using two kinds of techniques, using software or hardware is used. Okay, so if it is a hardware technique, we are going to use a low pass filter. Okay, the filter, it has a capacitor and a resistor. The capacitor takes time to charge. Okay, and even the capacitor takes time to discharge. That is the work of the low pass filter. So when the capacitor, as soon as the capacitor charges as well as the discharges, the noise which is erased due to the mechanical vibrations, it may be removed by means of the low pass filter. This is one of the technique which is called as hardware keypad debouncing. So another technique is used which is called as software keypad debouncing, where a particular delay of time is initiated in between the keypad. When the keypad is pressed, or when the keypad is continuously pressed after a stipulated time, the software debouncing, it may analyze that this is the key 9 is pressed continuously, hence the user is pressing, it is not because of the mechanical vibration. Okay, so that thing should be taken into account. You can see this is the flow chart for the key pressing. Okay, so initially all the rows, here I am taking I as rows, all the rows are not pressed. Okay, so we will be scanning or reading the rows each and every instant of time. Okay, so if any keys are pressed, that means what happens, there are two conditions, no as well as yes condition. If the keys are pressed, checking for any keys to press, if there is no key pressed, that means the value of I, the row value, why we are setting as 4 means you have 4 rows, right? So the value of I is less than 0. it will check for the less than 4 conditions. Any of the rows are pressed. Okay, if any of the rows are pressed, it again goes to scan the row. If none of the rows are pressed, that is no condition. Okay, so no condition means it goes to the 0 condition. If none of the keys are pressed, that means the row becomes I is equal to 0. If any of the keys are pressed, that means it may be I is equal to 1, I is equal to 2, or the row it may be 3. That means it again go for scanning condition. Okay, now the next condition is about pressing. We are pressing the key. That means if it is true, that means the key debouncing software will wait for a stipulated amount of time. So I am setting the time to be 0.1 seconds. So it will wait and check whether the key is still pressed. If the key is still pressed, that means here also we have two conditions, no as well as yes. Okay, if the key is still pressed, if the condition fails, that means the software will analyze it is because of mechanical vibration. Actually the key is not pressed. Okay, if still the key is pressed, if it is true, what happens? Actually the user is pressing any one of the key. Okay, right, and also it goes to the less than condition. Okay, so this is about pressing the key in an keypad. Okay, so we have formulated a pseudocode for this. Scan a row of keys to see if any are pressed. If a key is pressed, perform software key debouncing. Wait a short period of time to allow key to settle. Confirmed key is still pressed. If the key is still pressed, input is valid. Repeat step 1 with the next row of the keys. Okay, and I have shared the revision questions with you. So these are some of the revision questions. It may be a 2 mark or it may be a 4 mark, whatever, but they are very important under this display topic. Please make use of it. So that's all about unit 5. It is a very small unit display, and make use of the slides. Stay safe and take more rest. Be healthy. Thank you.